All right, so as I said, we're going to get through this chapter 0 chapter first, and it's just kind of a grab bag of stuff. So the first two sections were converting units. I skipped the second section because it was just doing the first section, but more complicated. Didn't really feel it was really applicable at this point, so I'm going to skip over that. Now, getting into section 3, we're going to be getting into simple probability. Now, for those that did not get in their work yesterday, I'm just going to give you the heads up that today's Thursday, so we're going to go over these. If I am not receiving anything from you by today, then tomorrow I'm going to be sending out emails to both you and your parents/guardians to kind of be like, hey, beginning of the semester, get off on a good start. Haven't seen anything, please reach out to me. So if you've been submitting your work, whether it's been right or wrong, it doesn't matter. As long as you've been submitting your work, you're good. But if you're one of the people that haven't been submitting anything, please expect an email from me tomorrow. All right, so simple probability. Couple vocab words to start off the lesson. First is an experiment. According to the book's definition, this is saying a situation involving chance. With math, sometimes words are used in specific situations and they give them, as in the world of mathematics, a definition that's applicable to that situation. This is one of those instances. You may know experiment to mean something else. In this case, the wording in the book is going to be that it's a situation involving chance. Now, every experiment has an event. An event is an outcome of an experiment. So you may do something, and whatever happens, that is the event. What we're going to be working on today is finding the probability of a certain event occurring. Now, a probability, according to the mathematical definition, is the ratio of the number of favorable outcomes to the number of possible outcomes. In simple terms, a ratio is just a fraction. So what a probability is that it's a fraction, and in the numerator, in the top, it's what we want to happen. And in the denominator, in the bottom, is what could happen. So the probability is the likelihood of a certain event occurring when an experiment happens. Now, the notation for the probability, because I don't want to write what is the probability of something occurring every time. I'm just going to denote that experiment to being event A. So instead of saying the words, what is the probability of event A occurring, I can switch my notation to having a P and then in parentheses the event that I want to find the probability of. So whenever you see this notation, it's talking about probability. Now, probabilities come in a range of answers. We could do it using percentages, then it goes from 0 to 100%. We could do it in decimals. It would go from 0 to 1. We can also do it in fractions, but I'm going to try to stay away from fractions for now because the golden rule with fractions is that you always have to reduce. And so what's kind of a shame is that if you leave your answers in fraction form, you may be correct, but you might lose points if you don't reduce your fractions. So I will accept percentages, I will accept decimals, and I will accept fractions, but if you don't reduce your fractions, then technically they're not correct. Now, from 0 to 1, if you get 0%, that means it is absolutely impossible for something to happen. If you get 1 or 100%, then that means it absolutely will happen and it's impossible not to happen. 50% means it could go either way. So when there's a 50-50 chance, that means either it could happen or it couldn't happen. There's an equal chance of both. The formula to figure out the probability, so the probability of event A, you take the number of favorable outcomes, so that's what we want to happen, and we divide it by the number of possible outcomes. So everything that could happen. With probability, there are two types of probability. The first is called a theoretical probability. This is what should occur. So theoretically, what should happen? This is when we just ask a general statement and we take the outcome for what the experiment is, not what actually happened. So for example, if I roll a 6-sided die, if I want the probability of rolling a 3, well, if it's a 6-sided die, there are 6 possible faces that could come up. There's only one face with a 3 on it, So the number of outcomes that I want is 1, because there's only 1, 3. And the number that could happen is 6, because there's 6 different sides. So therefore, the probability of rolling a 3 of a 6-sided die, the theoretical probability, is 1/6, which is about 17%. The other type of probability is experimental probability. So that's what actually does occur. So it doesn't matter what the fates say should happen. Like if you flip a coin, it should be a 50-50 shot. Experimental is what actually occurs. So let's say I roll that same 6-sided die 5 times with the results of 1, 3, 4, 3, and 2. Meaning I rolled the die and a 1 came up, a 3 came up, a 4, a 3, and a 2 came up. So I asked the same question. What is the probability of 3 occurring? Well, in this case, a 3 came up twice. So the number of favorable outcomes was 2. And I rolled it 5 times. So my denominator is 5. Therefore, the probability of rolling a 3 went up from 1/6 to 2/5, which is about 40%. A couple practice problems. Let's look at example 3 first. Suppose a bag contains 4 red, 3 green, 6 orange, and 2 yellow marbles. Find the probability of drawing a yellow marble, the probability of a red marble, the probability of a green or an orange marble, and then is this example theoretical or experimental? You may want to pause this video and answer these 4 questions before moving on. Alright, before we go over the answers, let's look at example 4. The table shows the results of 25 die rolls with the frequency on each side. So this table, the outcomes are 1, 2, 3, 4, 5, and 6, because those are the potential outcomes of rolling a die. And the frequency is how often that side landed face up. So I rolled a 1 6 times, a 2 4 times, a 3 7 times, a 4 3 times, a 5 4 times, and a 6 1 time. So now asking similar questions, what's the probability of rolling a 4? Now keep in mind, this is experimental. So my denominator should be out of the sum of these frequencies. So I rolled it 25 times. So each one of these is going to be divided by 25 instead of what I'm dividing by up here. What's the probability of not rolling a 5? What's the probability of rolling a 2 or a 1? And then would this be theoretical or experimental? So take some time, pause the video, answer these questions. The next piece of paper is going to go over each of the answers. All right, here are the answers to example 3. So for number 1, the answer would have been 2/15, or about 13%. Number 2 was 4/15, or about 27%. And 9/15 reduced down to 3/5, which is 60%. The decimal would have been 0.13, 0.27, and 0.6. This would have been theoretical because no trials were recorded, and I was just taking it off of what was in the bag and what could have happened. Example 4. Number 1 was 3/25, or 12%. Number 2 was 21/25, or 84%. Number 3 was 10/25, which reduced down to 2/5, which is 40%. Each decimal equivalent being 0.12, 0.84, and 0.4. This one would have been experimental because trials were recorded and the probabilities were dependent on those trials. So hopefully that makes sense. The homework for tonight, I'm just going to go right over to the textbook here. It's on page P9, numbers 1, 5, 9, 13, 15, 17, 21, and 22. So to get a closer look, there's 1 and 5, there's 9 and 13. Zoom out so you can see those directions, 15 and 17, and then 21 and 22. Now I will be taking a picture of this so you can zoom in as needed. Good luck.